Once we have found our line of best fit, we can use it to make predictions. So we're going back to the hours spent studying versus the final exam grade. And our line of best fit was y equals 6.09x plus 63.93. And the x stood for the hours and the y stood for the score. And this line of best fit we would use to predict a score based on a certain number of hours, or predict the hours based on a score. So it's asking us to find the final exam grade for a student who studied for 2.5 hours. So what I'm going to do is I'm going to say y equals 6.09 times 2.5 plus 63.93. I'm going to type that into my calculator. So 6.09 times 2.5 plus 63.93. And I can expect that they're going to get approximately a 79.155. So 79.155. Okay. And then 6 hours, we would do the same thing. So y equals 6.09 times 6 plus 63.93. So 6.09 times 6 plus 63.93 is about 100.47. So what that's saying is that someone who studies for 6 hours can expect to get a perfect score. So 100.47. Now, if a student earned a 98 on the exam, this is a score. So we have a score, so we're going to put that in for the y instead of putting, like we have, the hours in for the x. So they got a 98, so we're trying to say a 98 equals 6.09x plus 63.93. And I would solve this like I would any other equation. I'm going to subtract the 63.93 from the 98. So 98 minus 63.93. And that's going to give me 34.07. So I can say 34.07 equals 6.09x. And I'm going to divide on both sides. 6.09, 6.09. Divided by 6.09. And so someone that wants a 98 is going to have to score somewhere around, or is going to have to study about 5.59 hours, 5.6 hours. Okay? I'm going to show you what this would look like on the graph. So on our Desmos graph, here we have all the way back in the beginning. So someone that studied for 0 hours, we have our y-intercept of 63.93. So 0 hours, they expect to get this score. 2.5 hours, they expect to get a 79.155. Right here, they expect somewhere around 98. And here at the very top, that was our 6 hour mark. And they expect to score over a 100. So these are the approximations based on the data, based on our original line of best fit that we took from our original data. You can take a second now to go back and look at your original data and see how this matches up.